So we're now going to look at details, and as I mentioned before, I just created some walls on the first floor and a suspended ceiling, and I told you I'd show you just how to create that as a sketch-based version, simply because we don't have this dividing or this boundary section here. So if we go to our first floor plan or level 1 plan, then we can see our floor, and if we go to our ceiling plans, then we can see the ceiling grid set up there. Now if I chose the ceiling tool on the architecture tab and I come to put a ceiling in here, it doesn't automatically go in because it's set to automatic ceiling. I can click on this one, sketch ceiling, and this gives me the sketch based tools which we are now very familiar with, and I could use the pick lines or I could just draw the line, and it's probably just easier to draw the line around the boundary and then stop it wherever you want it. If I wanted my suspended ceiling to run to this edge, so it was more in line with the back of this, then I could just hit escape a few times, close out of that, select the ceiling, and then just edit boundary. And I can come in, just drag this in a bit to line up with, that's a bit too far, let's take it to that point, there you go. And then I can say OK to that. And I might want to sort of tidy up the positioning of the tiles. We have got a little bit of an issue with a small tile there, so you might want to push it forward so you've got a 3/4 tile there and maybe a 3/4 tile this side. Let's not get bogged down on that sort of thing, but anyway, that's how you put a suspended ceiling in. So now we can go back to our level 1 plan and let's have a look at our section cut. So we can either double click on this bit or we can right click and go to view. So here we are with our section. I've created 2 callouts. They're very simple things to create. Use the callout tool, and you've got 2 options. You've got the rectangle option, or you can have a sketch based option, but the rectangle option is the one I've used for these. It creates a rounded corner rectangle. You just click and then just drag it around something, and then that's created a reference callout. These things don't populate until you put the call out into a sheet. More about that another session, but that's what it creates, and it pops it down in the sections section. So section 1, call out 1, 2 and 3. If I delete this one, then section 1 call out 3 will be deleted. That's okay, we can do that, and then that's gone from there. So everything's referenced in this program, which hopefully you should be fully aware of now. So if we look at the detail, basically a little bit about these sorts of things. This is the sort of information that you get at this sort of scale. Now you might want to tidy some of these things up and model it slightly differently, or change it with some model lines or detail lines sort of in this sort of area. But effectively, this would be good enough for referencing this area. So when you are producing a sheet and this was represented at 1 to 50 or 1 to 100, then this would be fine. I mean, it's basically giving you the grid reference and the level information, so that's pretty much all you need. And then we go in and we work up the details in 2D, not 3D. It would be far too costly as far as time and modeling capacity went to create 3D everything and hope that we could see everything, because Revit has a way of displaying certain objects at certain line thicknesses when they're cut, but not every object. So certain things like furniture, for example, that doesn't have cut styles because it's just too complicated to sort of start showing all of that information. It's only the general modeling stuff that we would actually see sort of in cut form. So a lot of stuff in Revit, contrary to popular belief, is drawn in 2D, and it's all drawn from this quite simple little panel. So you've got the detail lines, which are again this sketch-based system, and we've got these types of lines that we can play around with. So these are our line types, and we have, if I just hit escape, then we have the region. So that creates a filled or a masking region. And again, when you create these sorts of things, you've got to be wary of the line type. If you're creating a masking region, you often want to have this invisible line, not the hidden line. Hidden line's dashed, but the invisible line would not generate a line at all. So if I just show you an example of that, I want to put a call out over something here. So invisible lines, and if I just click and create a masking region and say OK, and that's basically blanked out that part of the detail. And this is what you can do on all these sorts of things. So I'll just select that and delete it. That's a 2D thing, and it lives specifically in this view, so you wouldn't hide other objects in the drawing. So we'll dig down into our detail. So if I click on the outside edge of the callout, right click and go to view, then we end up in this sort of view. Okay, so now we've got the grid line and the reference level. So we can start putting in, all sorts of things, dimensions, text. We can change the scale, so it's set at 1 to 25. We'd probably want this to be about 1 to 10. So we'll just do that, and it just tightens everything up, makes everything slightly smaller. So then you start to appreciate that maybe you want to bring this in a bit, and you can do that by clicking on the edge and just dragging this down and dragging this in. There's two lines you notice, a dotted line, which is the extents of the callout, and this one, which is the crop boundary. And I'll just bring that up as well. We've got to include our suspended ceiling in there. And more about these two things later. You might wonder what these things are. These are breaks. So if I clicked on that bit, then I could break this into 2 bits. And to join it back up, I just drag this down and let it go on top of that one, and you get a little warning. Just ignore that. So it's joined back up. So you can break these things and move them around independently as well. So what we're looking at here in this detail is the first floor, which is a chorus sort of tin lid with a bit of concrete poured on top, and that sits on top of this beam here. That beam is attached to this thing. So again, you might want to, if it's a shear connection, you might want to show the plates and the bolts, so these can be drawn in and highlighted. We've got these things which are cladding rails, and we've got our curtain wall system, which the mullions are here, and this is a panel, and this is the glass. Okay, so what we want to do is sort of show much more detail in this sort of area, and we don't necessarily draw it from these lines, though we could. Let's cancel out of that. We could just start drawing in more complicated shapes, but the beauty of having these 2D elements is that simply we can use pre-existing details that have been generated in AutoCAD, for example. And so what we're going to do in this tutorial is to, from AutoCAD, create some AutoCAD files and then import them into a detail family, and then bring that detail family into this model environment as a 2D object, and then we can do all sorts of different stuff with it. But it is quite a simple process. It's just a question of bringing in and referencing in external materials or external drawings, and then putting them into place. It is important, however, that, for example, this curtain wall system, that matches up with the type of mullion that we're bringing in. It's pointless having this modeled as a whatever size it is. Let's just do a little check, zoom in a bit. So this is 63 by, say, 190. If our corresponding detail was slightly bigger or slightly smaller, then we'd need to make sure that this, as far as the model went, corresponded with that, because that might have effects on the positioning of these things, and lots of things down the way. So even though we're not showing this in a very detailed way, we do need to make sure that the sizes are matching up. Okay, so we're going to go to AutoCAD and have a look at the CAD files that we've got to play with. Now, there's no point in making these things up yourself. You need to go to the manufacturers to get information from them. This is Cornier, where I got the CAD files for the curtain wall system, and they also provide some BIM models as well, so you can use. Okay, so lots and lots of information from their technical resource center. So you've got all the information that you'd ever likely to need, and then there'll be CAD files and curtain wall systems as well. Okay, so that's the sort of thing you need to do. Don't guess this stuff. Go to the manufacturers and find out exactly how these things go together. It just builds up your knowledge of the product as well. So from a site like this, for example, then into AutoCAD where you can download their products, and we've got, I've tidied this up a little bit, detail 1, detail 2 and detail 3. Because of our section cut is coming through sort of this face, then we've got this information here. Now one thing I've noticed is that the curtain system that I've put in the BIM model is back to front. So the glazing goes on the outside of this little cap, and then the business end sort of goes toward the inside of the building. So one of the things that we'll be doing in our Revit model is flipping the curtain wall system so it faces the correct way. So what you would do, and this is entirely up to you how you do this, would be either to create sort of CAD files of these individual bits. You wouldn't necessarily need all of these lines here. What you're looking for are the main elements that make up the curtain wall system. So you could either just go for something like this bit on the outside. Alternatively, you could have this bit on the outside and then this bit on the inside, and you could create sort of another family of screws. This thing could be another thing, and you could build it up as several different elements. There's no restriction really on how you do this inside of Revit, but pick a method and we'll go from there. What I'm going to be doing inside the family is building elements from this CAD file. So this outer bit, then the inner bit, and then this bit, and some of these bits as well. So this will take a little bit of time. I'm not going to go through the whole process. What you could do, however, is to strip out all of these things and just get down to the main guts of it, and you can make some of the stuff up yourself. And in AutoCAD, just put a fill in some of these areas. So that's another way of doing it. So you would use the hatch tool and maybe pick a solid hatch, and then we can come inside these areas and this one, and then that would be the information that you would be able to take into Revit. Okay, so it's not necessarily you have to do it the way I'm going to show you, but the reason I'm going to show you this technique is simply because you might want to use it for other things where we use pick lines and create a filled region of a complex shape. Okay, so we'll leave AutoCAD and go back into Revit, and then we'll look at the Revit detail family environment.